After completing the course, you will be able to understand the basics of network concepts, source transformation, what you mean by source shifting, mesh node analysis to solve the networks, and a number of problems on the concepts. It is covered in the first module, and second module and onwards, networks theorem and initial and final theorems, and the concepts related to two-port networks. Those things will be covered in second, third, fourth, and fifth module. So let us concentrate on the first module. So that covers definitions of basic terms like what you mean by circuit, network, current, voltage, and passive elements like resistor, inductor, capacitors. Then what you mean by series, parallel connections of resistors, and after discussing the definitions of all those things, we do discuss what you mean by star connections, delta connections. After that, we do discuss what you mean by source transformation. So before that, you will come to know what you mean by source, types of sources like current source, voltage source, dependent, independent. All those things will be discussed. After that, how to convert one form of source into another form of source. That is nothing but a source transformation. Okay. Later, we'll discuss a source shifting. Once those things are covered, what you mean by mesh, node, later what you mean by a mesh analysis for the networks, node analysis for the networks. All those things will be discussed, and we'll solve numerous problems on those concepts. All right. Now, we do start the network theory subjects with a few definitions. So after the completion of these all things, we can touch some few problems on the series and parallel networks. Okay. So what do you mean by a circuit here? Simple circuit or electric circuits, one another same. So here it is written here, I do read now, any path along which electrons can flow. So electrons will only flow if the circuit is complete with no gaps. All right. So I will take here a whiteboard. Here I have said a circuit means there should be a closed path where electron can flow. I do draw here simple circuit. I do draw here simple circuit where the resistor along with a source is available. A source is written as a V, and this is a resistance, and this is a resistance R. What is network here? What is circuit? The circuit is this one where the current I is flowing through a resistor R. This current is I is because of the source voltage V. So we can call this as a circuit here. So we can observe here the definition. Any path along which electrons can flow. Here this is the path where electrons, that is nothing but a current, can flow. And we do find no gaps. I will tell you what do you mean by gap here. So I will draw the one more circuit here. The same circuit, same resistor R, a voltage V, a current I. The difference between these two here is, here current in this case it is 0 amps. Current in this case it is 0 amp. So you can observe it is a circuit, but it is not a circuit because we do find here the gap that is said here. That is said here. Then what it is called? What about this? We can call it as a circuit because there is a complete path for the flow of the electrons. Then it leaves from the one node and it reaches to the another node. Then we can find here the path for the flow of the electron. That's why it is called as a circuit. Then what about this? I will tell you. There is, for that there is a one more definition. That is what electric network, or simply the network. An electric network need not contain a closed path for providing a flow of electrons. All right. So here it is a circuit. Here it is a circuit. The condition is the gap is available so that no path for the flow of the electron. So that it is not a circuit, but it is a network. That is the difference here. That is the difference between circuit and the network. Network means there may be chance of a complete path or no complete path for the flow of the electrons. Circuit means there must be a path for the flow of the current. Then can you say that all electric circuits, you can say all electric circuits are electric networks, but converse need not to be true. Is it right? So in this case it is a network but not a circuit. For this we can say that it has a circuit as well as a network. All networks are a circuits, but all circuits are not network. All right. So let us see what do you mean by current. We see what do you mean by current here. Current, I do read the definition of a current here. A current I, current I current I flowing through a conductor is nothing but the time rate of flow of charge. So you can one animation JIP is written here. So it consists of a wire, a battery, and the a resistor. In the place of resistor here, the bulb is used here. A 6-volt bulb, a 6-volt battery, and the wires. So in a wire, the current I is flowing. You can observe here. So this is a battery. From this battery, the electrons are going. So you can see it can be compared with a truck with some goods. So in that goods, 6 materials are carried. You can see here 6 balls are available here. Those 6 balls are nothing but electrons. They are coming from the battery and they are going towards the bulb. Because of these 6 items, the bulb is glowing here. All these 6 items are used by this bulb, then while returning back to the battery, they are empty here. They are empty. So these are nothing but electrons. The rate of flow of charge. The rate of flow of charge. That is nothing but here. Correct. Hope you have understood the meaning of the current here. We can, and mathematically it can be written as current I can be written as the rate of change of the rate of flow of charge, that can be mathematically expressed as dq by dt, where q is the charge and its unit is coulomb, t is the time and its unit is a second. Okay, always the unit of the current is ampere. Keep that point in your mind. Unit of a current is ampere. Okay. There are two more concepts, that is electron current and a conventional current. What do you mean by these two? Okay. Whatever you are observing in this GIF, it is an electron current. Always, it is a positive terminal of the battery and it is negative terminal of the battery. Electron current, electron current, electron current always flow from the negative terminal of the battery. It reaches to the load and comes back to the positive terminal. So electron current flows from negative terminal of the source to the positive terminal. Current, you just keep the point in your mind. It is a flow of the current. It flows from a negative terminal of the source and it reaches to the positive terminal. That is what the electron current. What do you mean by the conventional current that is needed for our calculation? So for our convenient, for our convenient, so we do give some modifications to the electron current as, so electron current flows from negative terminal to the positive terminal, but the conventional current always flows from the positive terminal to the negative terminal. That's I will say here. Let us consider here. Let us consider same resistor with a source, same resistor with voltage source V. Okay, it is resistor R, it is voltage V, and it is a current I. So electron current will flow from a negative terminal to the positive terminal. Electron current will flow from the negative terminal to the positive terminal. This is nothing but the electron current. But you can observe here the one more symbol. This symbol, this is nothing but the conventional current. Conventional current, and it is the electron current. I hope I reached the point. Okay, so electron current in simple definition, it is a flow of the electron. It moves from negative terminal to the positive terminal of the source. So conventional current, it always it always flows from the positive terminal of the source towards the negative terminal. All right. And our next definition is, what do you mean by a voltage? I do read the definition here. The voltage V is nothing but an electromotive force that causes the charge electron to flow. So the voltage V is nothing but an electromotive force that causes the charge or electron to flow. Mathematically, it can be written as dW by dQ, where W is the potential energy and its unit is joule. Q is the charge and its unit is a coulomb. It is measured in terms of volt. You keep the point in your mind. It is measured in terms of the voltage. Okay. So two GFs are here. What is the difference between these two? It's the same 6-volt battery in the both the cases. In both the cases, all right. In these two cases, a 6-volt battery is used. Instead of one bulb, here two bulbs are used here. So in the first video, in the first image, 6-volt, it is giving 6 loads, 6 items in a truck. That is the flow of the current. All those 6 items are consumed by the bulb so that it is glowing. While returning from the load, all trucks are empty here. Okay. Instead of the single bulb, two bulbs are connected. They are in series. They are in series. So the nature of each load is it consumes only 3 items. Each truck carrying 6 items. When it reaches the first bulb, three loads are consumed by the first bulb. You can observe here, once the truck passes from the first load, it is having only 3 items here. those three items are consumed by the next series element, that is load. After coming out from the two loads, again the truck is emptier. So that why it is why I'm showing this image, because it is a concept of a series connection. Series connection. All right. Next, we do discuss the definition of a power. Power. What do you mean by power? The power P is nothing but the time rate of flow of electrical energy. Mathematically, it can be written as P is equals to dW by dt. Already we have discussed. W is the electrical energy and it is measured in terms of joule. And the T is the time and it is measured in terms of seconds. All right. A slight modification to this mathematical expression. So it is the dW by dt. Let us multiply and divide the dq by dt. Let us multiply and divide the dq on to this equation, so that it becomes dw by dt into dq by dt. So what is this dw by dt? It is nothing but the voltage V. Dq by dt, it is nothing but and current I. So that one conclusion is the power is nothing but the product of voltage V and the current I. Its unit is watt. Okay, so a power is nothing but the multiplication of the voltage and the current. We have discussed what you mean by voltage and what you mean by the current. So one more GIP is available here. One more the GIP is available, but what is the difference between the previous one and this one? Same two loads are used here, same one battery. In those cases, each load was 3 volt, but here there are 6 volt. But the connection is different. They are connected in parallel. They are connected in parallel. So what is the difference here? Same. Consider a truck, each truck carrying the 6 items. For the two loads, all 6 items are delivered here. While coming out of the load, the trucks are empty. You can observe here. So what is the difference between the series connections and the parallel connection? In the a parallel connection, you can observe here the voltage remains the same because 6 items are delivered for the two loads because of the parallel connections. But in case of the series, only 3 items are delivered out of 6. 3 is shared with the first load, another 3 is shared with the next load, because they are connected in series. All right. So just I wanted to say what do you mean by the series connection and the parallel connections while discussing with the definitions of the current, voltage, and the power. So in detail, we'll discuss what do you mean by series, parallel, what do you mean by these things in upcoming slides. All right. We do discuss what do you mean by open circuit. What do you mean by the open circuit? Okay. These are the circuits and they are broken and do not allow the flow of the electrons. That is called as a open circuit. We can consider an image. It is an example for the open circuit. The voltage is there, the load is there, load bulb, it is nothing but a load, or you can say it as a resistor, and the connecting wire. But one terminal is not connected to the battery, so that there is no chance for the flow of the electron to reach from one terminal to the another terminal. If this is the case, means we can say that it has an open circuit. So how it can be analyzed, how it can be seen? So the resistor means it is a bulb, battery is there, and it gives the voltage V. One terminal is connected, but another terminal is open, so that there is no flow of the electrons. That's why the current I is 0. This is the resistor. In this place, what is used? The bulb is used here. So we can calling this as a open circuit because what is the reason? We are calling this as a open circuit because no flow of current, because no flow of charge. What is the reason? Why it is not happening? Why the charges are not flowing? Because circuit is not closed. All right. I hope you have reached the definition of a open circuit. Then what do you mean by closed circuit? What should be the difference between these two terms? That can be visualized using this picture here. You can see here, same battery, same bulb, same wires, but the bulb is glowing here. The reason is there is a closed path for the flow of the current here. Then what will be the difference between closed and open circuit? I will write here a resistor, battery, and this is the resistor. So it is nothing but a bulb, and it is voltage, and there is a current, but it is not zero here. We are calling this as a closed circuit because there is a flow of the charge, because there is a closed path. I hope you can understand. You have understood the definitions of the open circuit and the closed circuits. Now, what do you mean by the short circuit? What do you mean by the short circuit? I do read the definition here. A short circuit implies that two terminals are externally connected with the resistance is zero, the same as an ideal wire, which means there is no it means there is a zero voltage difference for any current value. Okay, so we can see this is the a short circuit definition. No load is connected. The no load is connected. Positive and negative terminals of the source are directly shorted. They are connected directly, and resistance of this path will be considered as a zero. If that is the case, means they are called as a short circuit. I hope you have understood the definition of a open circuit, closed circuit, and the